Hello everyone, welcome to this video. My name is Peter Scarf. I am the creator of Workers for LabVIEW, and welcome to Workers 4.0. The goal of Workers 4.0 was to allow the development of Workers applications on NI real-time targets. And this requirement drove the development of several new features in the framework. For example, the Workers Debugger is now the Workers Debug Server, which connects to Workers applications over a network, allowing you to debug and observe your applications remotely, independently from the platform that they are running on. Workers 4.0 introduces a non-reentrant form of a Workers main VI, which is useful when using the standard LabVIEW debugging tools to debug a Workers queued message handler when developing on a real-time target. TCP server and client workers have been added to the Worker plugin library, and you can use these workers to stream data between Workers applications running on different targets. And other tools that are not related to real-time development but have been added to Workers 4.0 include the Create Base Class tool, the Change Worker Inheritance tool, and the MHL Case Viewer tool. And these tools help you when you inherit your workers from a worker-based class. In this video, I will demonstrate number 1, how to develop a Workers application on a compact cRIO. Number 2, I'll demonstrate how to use the Workers Debug Server to observe the application running on the compact cRIO. And number 3, I'll demonstrate how to use the new TCP server and client workers to stream data between an application running on a compact cRIO and a Workers application running on a Windows host PC. So let's start the demonstration. Next to me, I have a compact cRIO, and it is connected to this Windows host PC over a network. I am running LabVIEW 2017, and I have Workers 4.0 installed into LabVIEW 2017. Now, Workers 4.0 is distributed as the Workers SDK. And the Workers SDK consists of 3 VI package manager packages. Number 1, the Workers Framework Core package. Number 2, the Workers Development Tools package. And number 3, the Workers Debug Server. And you need to have all these packages installed into LabVIEW to develop with the framework. So as you can see, I already have set up a project in LabVIEW containing the real-time target, containing the cRIO, which you can see right here. So the first thing I'm going to do is to add a worker to our real-time target. So to do that, I'm going to open up the Workers Tools menu. And you'll notice that in Workers 4, the Workers Tools menu has been upgraded. There is a new tool here on the right called RT Worker Convert. I'll demonstrate the use of this tool later on in the presentation. And there is a new drop-down menu called Selected Target. You will only see this drop-down menu if your project contains a real-time target. So let's select the Created Worker tool. You'll also notice that the Created Worker tool has been upgraded since Workers 3.1. We want to create a worker without an event handling loop. We don't need our Workers queued message handler to handle front panel events. So we can select a worker without an event handling loop. Let's give our head worker a title. You'll notice that there is a new option here, which is ticked by default, and it says create non-reentrant worker for real-time targets. What this means is that when this option is ticked, this tool will create a worker with a non-reentrant main VI. And this is what we want when we are developing a Workers application on a real-time target. I'm going to add a header for the Workers icon and select Create Add. And just like when you're developing when you're creating a Windows application, this tool will add the worker to the project in the target, and will also create a launcher VI for the application. And there we go. We have the launcher VI and the worker now on our target. If we have a look at the contents of the worker, we can see that it contains a main VI with a file name main.nr.vi. This is the file name given to a non-reentrant main VI. If we double click on it and have a look at its icon, the icon takes this little NR designation in the bottom right hand corner, meaning that this particular main VI is non-reentrant. And you can use workers with non-reentrant main VIs in the same way you would use a worker with a reentrant main VI. The only difference is that you can't load multiple instances of the worker's main VI at the same time. So most of the time, unless you are developing and debugging your workers on an NI real-time target, there is no real advantage of using a worker with a non-reentrant main VI. If at any time you want to convert your worker's non-reentrant main VI to its reentrant form, there is a new tool for that, and I'll demonstrate that now. And this tool is the RT Worker Convert tool. This tool here allows you to convert a worker's main VI between its reentrant and non-reentrant forms. The column on the left shows workers in the target with a reentrant main VI. The column on the right shows all workers on a target with a non-reentrant main VI. So I'm going to select our worker that we currently have on the target with its non-reentrant main VI, and I'm going to select convert to main.vi. And we can see now that our worker's main VI, its file name has changed to just main.vi. And we can see that the NR designation on the icon of the VI has also disappeared. However, we are developing this application on a real-time target, so therefore we want to convert it back from its reentrant form now to its non-reentrant form. So I'm going to select the worker again and select convert to main.nr.vi. And once again, the worker's main VI is now in its non-reentrant form. The next thing I want to demonstrate is the use of the Workers Debug Server. So I'm going to open that now through the Workers Tools menu and select Workers Debug Server. The Workers Debug Server is a separate standalone application that can connect to Workers applications running on a network, such as this compact cRIO, or running on the host PC, or an application running in an executable. So the debug server is loaded. I'm going to now connect to the debug server. To do that, you need to go to the launcher VI of the application running on the compact cRIO. And this VI needs to be called before the main VI of the head worker in the application. This VI here is called Debug Client Loader. And what this VI does is it loads a background task that will connect to the Workers Debug Server to pass the debug server debug information from the Workers application. One of the inputs on the Debug Client Loader VI is the IP address of where the debug server is. So this is the field that we need to enter so that we can establish a connection. So the debug server is running on the Windows host PC that I'm recording on right now. So I'm going to find its IP address. So an important thing to note is that the debug server will listen on all Ethernet adapters, all the IP addresses available to it on the hardware that it is running on. The IP address of the compact cRIO is 172.2.2.1.1. Therefore, we need to use this IP address here. So I'm going to copy that and paste it into this field. And now I'm going to run the application on the compact cRIO. And we can see that the application has appeared in the Task Manager tab of the debug server. Here we can see the name of the worker, and next to it we can see the IP address of the compact cRIO. So there is a new right-click menu option for the Task Manager tab, if I select the cRIO target worker and right click, I now have the option to send a start exiting command to the head worker remotely through the debug server. So this is a great way to be able to shut down, start exiting your applications remotely. And now we can see that the little dot that was green has now turned red, meaning that the cRIO application has disconnected itself from the debug server, and the status of the application has changed to exited. And we can see now that the launch VI is no longer running. The next thing I want to demonstrate is the use of the new TCP server and client workers. So I'm going to go to the Workers Tools menu again, and I'm going to select the Worker Library tool. And here you'll see the new Workers for Worker Library tool. The Worker Library contains pre-developed workers that you can use in your applications to add additional functionality to your applications. And these workers contain an API that allow you to send requests to the worker and get responses back from the worker. So the new addition in Workers 4 is this TCP server and client worker library. So I'm going to select that and I'm going to click Add Selected Item to Project. And what this tool will do, it will create a copy of the TCP server and client worker library and add it to your target. And now you can see in our target we have this new item, TCP server and client.lvlib. If we have a look at its contents, we can see that there's two workers in it. One is a TCP server and one is a TCP client. We're going to be using the TCP client worker for our application that we're developing on the cRIO, and this is going to later connect to a Windows host application which is running the TCP server worker. If we have a look at the contents of the TCP client worker, we'll see that there is a public API virtual folder, and in it there are two other virtual folders. One is called requests. This folder contains VIs that send messages or requests to the TCP client worker, and there is a folder called responses. The VIs in this folder are used to convert message data that is sent from the TCP client worker to its caller, and these VIs convert the data in the message to the correct data type. And there is a VI here called create client. So now I'm going to plug in the TCP client worker into our application. So I'm going to open up the queued message handler of the head worker of the application, and I'm going to go to the all sub workers initialize case, and in this case I'm going to add the create client VI, and I'm going to wire it up. This VI takes two inputs. It requires the names of two cases that the TCP client can send responses to when something happens in the TCP client. The first input requires the name of a case that the TCP client will send a message to when there is either a connection or disconnection between the client and a TCP server. The second input requires the name of a case that the TCP client will send a message to when it receives data from a TCP server. So first we need to create these cases so that they can receive the messages from the TCP client. So I'm going to add a case called connection notify, create a case label using the Control 9 quick drop shortcut, and then I'm going to wire this case label called connection notify to the create client VI, and then I am going to add in the connection notify case the response VI, which again will convert the data in the message from the TCP client to the correct data type. which is this cluster here, which provides information about the connection or the disconnection from a TCP server. Okay, I'm going to add the received data case now. I'm going to create a case label for this case. Wire this case label to the create client VI. And then add the received data response VI to convert the forwarded data in the message from the TCP client worker. And there we are. So now when the TCP client worker receives data from a TCP server, it will forward this data to this case. The data will be converted from its variant form into the data string and the name of the server. Okay, done. So we are almost finished now plugging the TCP client worker into our application. What we want to do now is we want to add this connect to server VI after the create client VI, so that after the TCP worker has been created, the first thing that it will do is connect to the TCP server, connect to a TCP server. And this VI requires 3 inputs. The first input is the name of the client. We can call it anything we want. Let's just call it cRIO target. The second input is the server IP address. The TCP server application is running on this Windows host PC. So we already have the IP address of the host PC. We found this IP address to connect the application to the TCP, to the debug server. So I'm going to copy this IP address, and I've already developed the Windows host application, and the TCP server is going to be listening on port 5000. So that's the connect to server VI all set up. And there's one last thing I want to do now. I want to demonstrate bidirectional communication between the TCP client worker and the TCP server worker. So what I'm going to do is I'm going to use this send string to server VI in this case. And I'm going to wire the received string to its input so that this VI will send the received data back to the TCP server. And we have now completed the integration of the TCP client worker into our cRIO application. So as I mentioned, I've already created the Windows host application, which is running on this Windows PC, and it contains the TCP server worker. I've created this application in the exact same way that I've created the application on the cRIO, but instead of using the TCP client worker and plugging this into our application, I've used the TCP server worker. So I'm going to launch now the Windows host application running the TCP server. And I'm going to run the real-time application that we just created. And if we look at the front panel of our the head worker on the cRIO. Yep, we can see now that both applications are running. The window on the left is the Windows host application. The window on the right is the application running on the cRIO. And we can see that a connection has been established between TCP server and TCP client. And we can see this from the server data cluster and the client data cluster on the front panels. We can see the information about the TCP server and client, and we can see that these connected LEDs are green, meaning that a connection has been established. Now let's have a look at the debug server. And in the debug server, we can see that both applications, both the Windows host application and the cRIO target application, both exist in the Workers debugger. Now, I'm going to type a string into this control, and the TCP server is going to send this string to the TCP client worker running on the cRIO. And as I type, you can see the indicator on the cRIO front panel start to populate. Hello world. And you can also see this indicator down here filled with the text that I'm typing, indicating that the data is being sent back from the TCP client to the TCP server. So I hope this demonstration helps to show how you can create a Workers application on a cRIO, how you can use the new TCP server and client workers to stream data between a Workers application running on a host PC and a Workers application running on a real-time target, and how you can use the Workers debug server to observe Workers applications running on both Windows and a cRIO. For more information about what's new in Workers 4.0, please visit the new Workers Online Help website. There is a link below that will take you there. And if you would like to download the application, the LabVIEW application that I created in this video, there is also a link below for that also.